Hello, welcome to Astronautics for Exploit. I am Dr. Ayanshola Ogundele. Lunar Orbital Nuclear and Surface Power Options, Viable Solutions to the Lunar Village Power Needs. The focus points of my presentation are as follows: Lunar Bases and Power Needs, Lunar Orbital Power Options, Lunar Nuclear Power Options, and Lunar Surface Power Option. As humans plan to explore space further and break more space exploration boundaries, electrical power and the use of moon resources in situ are very important for the successfulness of various space exploration endeavors. The use of in situ resources for space manufacturing is necessitated by the high cost of transporting resources from the Earth to the Moon. Since the conception of the idea of manned lunar base in 1950s, power has been identified as an important component. Presently, based on the importance of moon exploration to the future ambitions to explore deep space, various lunar-centric research endeavors and focus are channeled towards developing state-of-the-art lunar power technologies that will be always available for use by the astronauts on the moon, rovers, and for powering the lunar bases. The three main lunar power options that are receiving tremendous research efforts are lunar orbital, nuclear, and surface power options. As a low-cost alternative to the nuclear fission reactor, lunar orbital power system is being proposed. A lunar space-based solar power system positioned in lunar orbit involves the use of solar panels to collect solar energy in space with reflectors or inflatable mirrors and then beaming it onto the moon via a microwave or laser. Findings showed that lunar solar power satellites could transmit power to the lunar outpost 2 out of every 8 hours. Example of lunar orbital station for power provision to the moon is the Lunar Gateway, the first planned extraterrestrial space station in lunar orbit, being aimed to be used as a solar-powered communication hub. Over many decades, various proposals for the use of nuclear fusion reactors to power lunar base have been developed. The use of nuclear reactor for power provision to the moon is found to be very reliable and thus ability to work for many years continuously, irrespective of the environmental conditions. For the lunar surface power option, researchers are working on power generation, transmission, and distribution on the lunar surface. For example, there is an ongoing work on the design and implementation of flexible energy distribution between micropower grids that can make use of battery sources, solar energy, and radioisotope. Lunar bases and power needs. On the moon, both manned and unmanned lunar missions are prone to a lot of challenges. One of the most significant challenges to the successful implementation of a continuously manned lunar base or unmanned robotic on the moon is the availability of a reliable power source that can meet the mission requirements for the duration of the missions. The picture here shows the Peregrine lander Odin 9 lunar experiments. There are various lunar missions and activities on the lunar surface that are being proposed. Examples are in-situ resource utilization processing heat and power, oxygen and raw material production, long-distance rover power, remote standalone geology station power, lunar village city habitat and base camp power, remote stand-alone astronomy observatory. The picture here shows illustration of a lunar mission on the lunar South Pole. Lunar bases and power needs. The amount and type of lunar power required by a mission is dependent on the mission type, manned or unmanned, that is robotic, and the requirements of the components or devices associated with that mission or activity. During the lunar day of 14 Earth days, it is conceptually simple to deploy solar arrays to generate the estimated 35 kilowatts of continuous power required. The picture here shows Artemis Base Camp. Lunar night. Generation of the level of power needed during the lunar night is an extremely difficult problem to solve. Conventional solutions involve locating the lunar base at the lunar south pole so as to take advantage of the continuous sunshine available to developing a space-qualified nuclear reactor and power plant to generate the needed energy. The picture here shows illustration of the laser power beaming at the lunar reconnaissance orbiter. Research studies on lunar south pole. Several research studies have been conducted by the space agencies, private space companies, universities, and a host of others looking at the lunar south pole for locating a base. Findings show that, taking advantage of the moon's orbital tilt, large solar arrays can be deployed to track the sun continuously and generate the power needed to sustain human presence. Illustration of a proposed industrial base for mining water and producing propellant at the lunar pole, featuring crew inhabitants, robotics, and industrial equipment, is shown in this picture. Lunar orbital power options. Space-based solar power. The concept of collecting solar power in outer space by solar power satellites and distributing it to Earth offers various advantages. Various researches and investment into the space manufacturing from asteroids or lunar material and development of radical new space launch technologies other than rocketry are making the development of lunar orbital power option to become a reality. Artist's impression of a moon-based concept is shown in this picture. Advantages of space-based solar power. Some of the advantages are highlighted below. Higher collection of energy due to the lack of reflection and absorption by the atmosphere, possibility of very little night, and a better ability to orient to face the sun. Space-based solar power systems, which convert sunlight to some other form of energy that can be transmitted through the atmosphere to receivers on the Earth's surface. The picture here shows Alpha Solar Satellite, a concept of space-based solar power. Solar power station. Presently, there is a proposition for the use of orbiting space-based solar power station to generate electrical power in lunar orbit and beam it to a lunar base or lunar village. The Lunar Gateway is the first planned extraterrestrial space station in lunar orbit, intended to serve as a solar-powered communication hub, science laboratory, and short-term habitation model for government agency astronauts, as well as a holding area for rovers and other robots. The picture here shows an illustration of the gateway's power and propulsion element and habitation and logistics outpost in orbit around the moon. Lunar nuclear power option is another option that is being looked at to power equipment on the moon. There are various proposals to build nuclear power plants on the moon and Mars to support its long-term exploration plans. The nuclear power plants will provide enough electrical power to establish an outpost on the moon or Mars. One lunar nuclear power idea is to fully manufacture and assemble nuclear power facility on the Earth and test it for safety before launching to the moon. The picture here shows interior of a 3D printed section of SS Plan Moon Village. Nuclear fission power. Nuclear fission power is another option that is being considered to power the lunar bases and villages. Compact fission reactors are commonly used on Earth to power systems that have the similar requirements, such as submarines and aircraft carriers. One of the considerations for the location of the nuclear power plant on the moon is safety. This is because of the radiation produced by the nuclear power sources. Inflatable model concept for lunar base is shown in this picture. Effects of placing nuclear reactor near the lunar base for the provision of electrical power are being examined through various research endeavors. One of the mitigations of the radiation from the nuclear reactor is to place the reactor far from the lunar base of village, behind massive objects to attenuate any radiation leakage, or behind or under artificial shading. The picture here shows artist's impression of a lunar base. Lunar surface power option is another power option that has been looked at for powering lunar village and equipment on the moon. Presently, there is a proposition for the use of orbiting space-based solar power stations to generate electrical power. Then, research is ongoing by the space agencies, private space companies, and universities to design lunar surface power option. Because of the Asia threat, the only location on the moon with continuous solar power availability is found to be the South Pole. Here, the sun is perpetually on the horizon. A solar array gimbal to track the sun as the moon slowly rotates will be relatively easy to build. Rendering of a kilopower reactor on the moon is shown in this picture. The main advantage envisioned for the location of lunar surface power on the moon is the construction, which could be done largely from locally available lunar resources, using in-situ resource utilization, with a teleoperated mobile factory and crane to assemble the microwave reflectors, and rovers to assemble and pave solar cells. Lunar surface power option will reduce launch costs compared to space-based solar power designs. The picture here shows astrobotic lunar grid concept. Solar power stations. David Criswell proposed using the lunar surface as the optimum location for solar power stations and promotion of lunar-based solar power. He also proposes beaming power to the ground via a series of microwave reflectors in Earth orbit or using the power on the moon basis. The main advantage of this approach is the ability to manufacture the solar collectors in situ without the energy cost and complexity of launch. The picture here shows Zambia National Laboratory's lunar microgrid concept. For more information, contact Astronautics for Exploit. You've been watching and listening to Lunar Orbital Nuclear and Surface Power Options, Viable Solutions to the Lunar Village Power Needs, with the focus points: lunar bases and power needs, lunar orbital power options, lunar nuclear power option, and lunar surface power option. Thank you.